Hi, hello, welcome everyone. Question says a radio used to take radio station 840 kHz frequency. If resonance 0.04 millihenry inductor, what's the capacitance of capacitor? Question says what's the capacitance, and it gives the information about resonance. So we can use the resonance frequency. Resonance frequency is equal FR equal 1 over 2 pi LC in root. So F is given, L is given 0.04 millihenry. Milli means 10 to minus 3 Henry. Pi is constant. Pi equal 3.14. And 2 is a number and 1 is a number. So I can calculate the capacitance. From there, capacitance is equal. We can use the cross multiplication. LC equal 1 over 2 pi FR. Take the square of both sides. It's going to be LC equal 1 over 2 pi FR, 2 pi FR squared, and C equal 1 over 2 pi FR squared times L. So now when we substitute the value, 1 over 2 times 3.14 times FR is 840 kilo. Kilo means 10 to 3 squared, and the L is given 0.04 times 10 to minus 3, and the C going to be 0.898 times 10 to minus 9 farad. Thanks for listening. Hello, welcome everyone. Question says what's the range of wavelength, and between these two frequencies, and C equal lambda times F. Lambda is wavelength and F is frequency. From here we can calculate the lambda, which is wavelength, C over F. So for F equal 540 kilo means 10 to 3 hertz. And by the way, C equal 3 times 10 to power 8 meter per second. So for the first one, lambda equal C, which is 3 times 10 to power of 8 over 540 times 10 to power of 3. The result going to be 0.055 times 10 to power of 4 meter. This is the first one. For F equal 1600, it says kilo again, 10 to 3 hertz. So lambda going to be, we are going to follow same way, 3 times 10 to power of 8 over 1600 times 10 to power of 3. So result going to be 100 87 meter. Hello, welcome everyone. Question says, what's the minimum length of car antenna with the frequency 100 megahertz? So F equal 100 times 10 to the power of 6 hertz. It means 10 to 8 hertz. And it says minimum length of car antenna. We are going to use half wave antenna. Why we are not using the quarter wave antenna? Because the car is not grounded. First of all, we have to find the lambda. Lambda equal c over fc is the speed of light. It is the constant 3 times 10 to the power of 8 over f equal 10 to 8. 10 to 8 and 10 to 8 cancel each other. We have 3 meter. And the minimum length going to be half wave antenna. As I said, it will be 3 over 2. That means 1.5 meter. Thanks for watching. Hello, welcome everyone. Question says, what is the wavelength of electromagnetic waves with 50 Hz frequency? That means F is equals 50 Hz. So to calculate the wavelength, lambda equal c over speed of light over frequency, and it's equal 3 times 10 to the power of 8, which is constant for the speed of light, and F is equal 50. It's going to be 6 times 10 to 6 meter. Thanks for watching. Hello, welcome everyone. Question says, what is the frequency of the following electromagnetic waves? A, for the A, is asking frequency. Frequency equal speed of light over wavelength. Speed of light is the constant 3 times 10 to the power of 8 over wavelength. First one 2.1 meters, so it's equal 1.4 times 10 to the power of 8 hertz. And for the B, we are going to follow same way. F equal c over lambda, c 3 times 10 to the power of 8 over lambda, 12 meters, so it's going to be 0.25 times 10 to the power of 8 hertz. For the C, F equal c over lambda, 3 times 10 to the power of 8 over lambda is equal 120, and it will be 0.25 times 10 to the power of 7 hertz. Thanks for watching. Hello, welcome everyone. Question says, an explosion occurred 4 kilometers away from an observer. What's the time between observers seeing of the explosion and hearing? To see, we have to use speed of light. To hear, we have to use speed of sound. So speed of sound is given 340 meter per second. And we have to calculate time. Let's calculate firstly for C. Time is equal, as you know, x over v. But to C we are going to use x over c, speed of light. And x 4 kilometer away, it says we have to use 4000 meter, and the c 3 times 10 to the power of 8 meter per second, and the result going to be 1.33 times 10 to the power of minus 5 seconds. Now we are going to calculate t here. X over v, x same 4000 meters over v 340 meter per second, and the result going to be 11.765 seconds. And to find difference between, we have to use subtraction method. T here minus T C going to give us difference between hearing and seeing the explosion. So 11.765 minus 1.33 times 10 to the power of minus 5, and the result going to be 11.764.99 seconds. This is the difference between hearing and seeing an explosion. Thanks for watching.